Hi all, welcome back to another session of Boilchem Tutor. So when we are learning chemistry, it is very important to understand the different elements present in the periodic table. Because when we are preparing for any competitive exam, one or two questions will be related to the periodic table and its properties. So in this session, I am mainly dealing with the first element in the periodic table, that is hydrogen. So when we are discussing hydrogen, it is the first element in the periodic table. It is having a simple H and having atomic number 1 and mass number 1. That means it is having a simple atomic structure with one proton in the nucleus and one electron in the extranuclear part. Again, when hydrogen combined with any other elements to form a compound, it can form compound by covalent bond as well as the ionic bond. That means it can form compound by sharing of electron or by losing or gaining of electron. And when we are discussing the oxidation state of hydrogen, it can form three different oxidation states, that is -1, +1 and 0. That is, when hydrogen combined with metals, it can form metal hydrate. At that time, the oxidation state of hydrogen is -1. But when hydrogen combined with non-metals like chlorine, bromine, iodine, etc., at that time the oxidation state of hydrogen is +1. Again, hydrogen can combine with another hydrogen atom to form hydrogen molecule. At that time the oxidation state of hydrogen is 0. Again, when we are discussing the order of abundance in the earth, hydrogen is the 9th element in the order of abundance in earth. That means it occurs 0.9% of the earth crust by weight. Again, the discovery of hydrogen, it is by Henry Cavendish in 1766. So coming to the method of preparations of hydrogen, first of all, it can be prepared by the electrolysis of water by the action of alkali or in the presence of acid. So when electrolysis of water in the acidic medium, so suppose if you are taking sulfuric acid also have a tendency to undergo dissociation by passing electric current. So sulfuric acid get dissociated into S plus as well as a sulfate anion. Similarly, water also undergo dissociation to give S plus and hydroxide ion. So when passing electric current, this H positive ion will liberated at the cathode and it will be converted into hydrogen gas at the cathode. But here there are sulfate anion and hydroxide anion produced, and so when on passing electric current, hydroxide ion will be liberated at the anode and it will be converted into oxygen at the gas at the anode. Because sulfate ion discharge potential is very high than that of the hydroxide ion, so sulfate anion cannot be discharged at the anode. So on passing electric current to water in the presence of acid medium, hydrogen gas will be liberated at the cathode and oxygen gas will be produced at the anode. Similarly, if we are carrying out the electrolysis of water in the presence of alkali medium, suppose if we are taking potassium hydroxide in water and passing electric current, potassium hydroxide also have a tendency to undergo dissociation to give K plus as well as the OH minus ion. Similarly, water also undergo dissociation to give H plus and OH minus ion. So here two cations are produced, that is K plus and H plus. So since the discharge potential of potassium ion is very higher than that of the S plus ion, the S plus ion will be easily migrated towards the cathode and it will be converted into dihydrogen at the cathode. And hydroxide ion will be migrated towards the anode and it will be converted into oxygen gas at the anode. So on passing electric current to water in the presence of alkali medium, hydrogen gas will be produced at the cathode and oxygen gas will be produced at the anode. When we are using active metals like sodium or potassium, it can react with water easily and liberate hydrogen gas. Similarly, when we are taking less active metals like zinc or aluminium, it can liberate hydrogen by heating with water. When we are taking metals like iron, cobalt, nickel or tin, it can liberate hydrogen gas by passing steam. Similarly, if you are taking metal hydrates like sodium hydrate or potassium hydrate, it also react with water and liberating hydrogen gas very easily. Another important method of preparations of hydrogen gas is that if you are taking metals like magnesium or aluminum or zinc, and if you are treating with any dilute acid like dilute hydrochloric acid or dilute sulfuric acid, it can easily liberate hydrogen gas. Similarly, if you are taking amphoteric metals like zinc or aluminum or tin, it can easily react with alkali and to form and liberate hydrogen gas by heating. Next, we can discuss how hydrogen gas is produced industrially. So, industrially, there are two methods of producing hydrogen gas. One it is Bosch process and other it is Lane's process. So, in Bosch process, we are using water gas. Water gas is a mixture of carbon monoxide and hydrogen, and which is mixing with twice volume of steam. And there is a requirement of catalyst in this process, that is Fe2O3, that is ferric oxide is used as a catalyst, and there is a requirement of promoter in this reaction, that is promoter can be used as chromic oxide, that is Cr2O3, or thorium oxide, that is THO2. And in this process, carbon monoxide undergo oxidation and it get converted into carbon dioxide and hydrogen gas is produced. In the second method, that is Lane's process, we are using superheated steam and which is passed over iron fillings at high temperature of about 1023 to 1073 Kelvin. And in this way, hydrogen gas is produced. Next, we can discuss the properties of hydrogen. When we look the dissociation energy of hydrogen, it is about 433 kilojoule per mole. That is, energy required to break the bond of hydrogen in hydrogen molecule is very high. So, the reactivity of hydrogen is also very less. But when hydrogen combined with active metals like sodium or potassium, it get converted into metal hydrate. That means hydrogen is here acting as an oxidizing agent. For example, when sodium react with hydrogen, it combine to form sodium hydrate. Here, initially hydrogen oxidation state is 0. But when it forms metal hydrate, the hydrogen oxidation state is -1. That means oxidation state of hydrogen is reduced to -1 in metal hydrate. That means hydrogen undergo reduction and that means it acts as an oxidizing agent. Similarly, hydrogen can also act as an reducing agent when certain oxides of a metal lying below the hydrogen in the electrochemical series react with hydrogen. For example, copper. Copper is less reactive than that of hydrogen because copper lies below the hydrogen in the electrochemical series. So when we are taking copper oxide and reacting with hydrogen, it gets converted into copper and water. So initially hydrogen is having the 0 oxidation state and it gets converted into water when it reacts with copper oxide. There in that water hydrogen oxidation state is +1. So hydrogen oxidation state is changing from 0 to +1. That means it undergo oxidation and that means hydrogen is acting as a reducing agent in this reaction. Again, hydrogen is used in the hydrogenations of vegetable oil. So when vegetable oil undergo hydrogenation in the presence of nickel catalyst, we are getting vanaspati ghee. Next, we can discuss the different isotopes of hydrogen. Isotopes are same element having same atomic number but different mass number. So hydrogen is having 3 isotopes. One it is protium, next deuterium and third is tritium. So out of these 3 isotopes, tritium is more radioactive and it acts as a beta particle emitter. And again, deuterium and tritium are used as a tracers in the study of reaction mechanism. Since the replacement of hydrogen by the deuterium or tritium slow down the reaction rate and thereby we can study the mechanism of that reactions. Next, we can discuss the different forms of hydrogen. First form is atomic hydrogen. Atomic hydrogen is formed when molecular hydrogen is passed over an electric arc struck between tungsten electrode. And the formations of atomic hydrogen is highly endothermic. That means large amount of energy is stored up in this hydrogen atom. And this liberated hydrogen atom can recombine to form the hydrogen molecule and with the evolutions of large amount of energy. And this energy can be used for the welding purposes. Again, the atomic hydrogen can be used as a powerful reducing agent and hence cannot be except at high temperature, that is around the temperature of the sun. So the next form of hydrogen is the nasal hydrogen. It is the hydrogen at the moment of its generation, that is when it is just liberated. This nasal hydrogen can be prepared in various ways, that is when we are taking a zinc and it is added to dilute sulfuric acid, we can produce hydrogen gas, and this immediately formed hydrogen gas can reduce the potassium permanganate. That is, if you are adding potassium permanganate to this zinc containing dilute sulfuric acid solution, the pink color of the potassium permanganate get easily decolorizes by the reductions of potassium permanganate with nasal hydrogen. But when some hydrogen gas is bubbled through potassium permanganate solution, the the pink color of the potassium permanganate won't decolorize. That means the nasal hydrogen is more active than that of the ordinary hydrogen, and hence it acts as a more powerful reducing agent than ordinary hydrogen. Next, we can discuss the different allotropic forms of hydrogen. There are two allotropic forms of hydrogen. One it is orthohydrogen and other is parahydrogen. So let us discuss in detail what is ortho and what is parahydrogen. So when two hydrogen atom combines, we get hydrogen molecule. At that time, the two electron spin should be in the opposite direction. Then only they result in the formations of a hydrogen-hydrogen bond in the hydrogen molecule. That is according to the Pauli's exclusion principle. But at that time, the spin of proton, that is proton is present in the nucleus, and this spin of the proton can be in the same direction or can be in the opposite direction. So, if the spin of proton is in the same direction, it is termed as the orthohydrogen. And if the spin of proton is in the opposite direction, it is termed as the parahydrogen. So, at ordinary temperature, the ordinary hydrogen contain 75% of ortho and 25% of para. And again, if the temperature is lowered, then the ratio of the orthohydrogen decreases and parahydrogen increases. And if the temperature is lowered up to 20 Kelvin, then it is pure parahydrogen. That means we can obtain pure parahydrogen. Again, in contrast, if the temperature is increasing, then if the temperature is heated up to 400 Kelvin, the ratio of ortho and parahydrogen is in the order that is 3:1. That means we cannot get pure orthohydrogen, but we can get pure parahydrogen, that is at 20 Kelvin. And again, when we are looking the chemical properties, they are similar. Ortho and parahydrogen is having same chemical properties, but physically they are having some properties difference, that is in the boiling point, specific heat and thermal conductivity, etc. And again, due to the difference in the nuclear spin, both are having different internal energies. Next, we can discuss the different types of hydrate. That is, hydrogen when combined with various elements to form a compound called hydrates. And there are three types of hydrate. One it is ionic hydrate. In this, ionic hydrate is otherwise called as salt-like hydrate or alkaline hydrate. As the name itself, we can tell that these hydrates are formed by alkali metals or alkaline earth metals. And again, this ionic hydrate act as a powerful reducing agent and act as a powerful dehydrating agent. For example, sodium hydrate or lithium hydrate or potassium hydrate, if you are taking, it is acting as a powerful reducing agent, and when it reacts with water, easily hydrogen gas is liberated. And so when these hydrate undergo electrolysis in the fused state, we found that hydrogen is liberated at the anode, because in this hydride, hydrogen is existing as H negative, and that means it is liberating at the anode. Again, when we are looking the thermal stability of this ionic hydrate, the thermal stability of this ionic hydrate decreases when increasing the size of the cation. That is, When we are taking lithium hydrate, sodium hydrate, potassium hydrate, rubidium hydrate, cesium hydrate, etc., lithium hydrate is having higher thermal stability than that of the cesium hydrate because cesium size is increasing and therefore thermal stability of this hydrate decreases. Again, when we look the alkali metal, earth metals also has a tendency to form ionic hydrate, and in that calcium hydrate is having the name that is hydrolith. So in several competitive exams, the name of calcium hydrate is asked. Therefore, calcium hydrate is termed as hydrolith. So next type of hydrate is molecular hydrate or covalent hydrate, and these hydrates are formed by nonmetals. And in these molecular lattices, the molecules are held together by a weak van der Waals forces. Again, when we look the stability, when we move down to the group, the stability of this hydrate decreases when increasing the size of the element. That is, for example, when we are taking the nitrogen hydrate, that is ammonia, then phosphorus that is phosphine, and arsenic hydrate, bismuth hydrate, etc. In this, ammonia will be highly stable and than that of the bismuth hydrate because the size of that element increases, so the stability decreases. Similarly, when we move from left to right in a period, the stability increases. Why? Because the electronegativity of that element increases. So when we move from methane to hydrogen fluoride stability increases than that of the methane because electronegativity of the fluorine is very high. Similarly, this acidic character also increases when we move from left to right in a period. And moreover, this hydrate is acting as a weak reducing agent. Next is polynuclear hydrate. Polynuclear hydrate are formed by certain elements like boron, aluminium, silicon and gallium. And in last session we have discussed about the boranes. That is, boron when combined with hydrogen, it results in the formations of different boron hydrate, that is otherwise termed as boranes. So this is a class of a polynuclear hydrate. Next classification of hydrate is metallic hydrate or interstitial hydrate. And these hydrates are formed by transition metals, and in these hydrate, hydrogen atom occupying the interstitial position of the metallic lattices. And these are also non-stoichiometric compound and act as a strong reducing agent. Next, I have selected some important questions from this topic which have asked in various competitive level exams. So first question is, nuclear isomerism is exhibited by. Options are given, that is molecular hydrogen only. Second option is all diatomic molecules. Third option is all diatomic molecules having even set values, and D option is all diatomic molecules having odd set values. So correct option is D, that is all diatomic molecules having odd set values. That means when atomic number is odd means there will be odd number of protons. So in the nucleus, so that nuclear spin will be there. So if there is a resultant nuclear spin means that compound can exhibit nuclear isomerism. So all diatomic molecules having odd set values can exhibit nuclear isomerism. So coming to the next question, that is acidified potassium permanganate solution is discharged when hydrogen is passed through it. Second option is zinc is added to it, and third is chlorine is passing through it, and D option is none. So we have already discussed in the session of nasal hydrogen that when potassium permanganate is added to a test tube containing zinc and dilute sulfuric acid, immediately the pink color of potassium permanganate is decolorized due to the reductions of potassium permanganate by nasal hydrogen. So when zinc is added to the acidified potassium permanganate, easily the pink color of potassium permanganate get discharged by the reductions of potassium permanganate. So the option is B. Coming to the next question, that is the metal which displaces hydrogen from a boiling caustic soda solution, that is sodium hydroxide solution, is. The options are given. A option is magnesium, B option is iron, and C option is arsenic, and D option is zinc. We have already discussed that when amphoteric metals react with sodium hydroxide, easily hydrogen will be liberated. So out of these options, the amphoteric metal is zinc. So option is D. So moving to the next question, that is hydrogen has 3 isotopes. The number of possible diatomic molecules will be, options are 3, B option 6, C option is 9 and D option is 12. In this case, hydrogen we have already discussed that it has 3 isotopes, that is protium, deuterium and tritium. And the diatomic molecules, possible diatomic molecule formed are HH, and it can be deuterium HD, and it can be HT, and it can be DD, that is deuterium molecule, and then it can be tritium molecule, and then it can be DT. So possible will be 6. So option is B. Coming to the next question, that is when electric current is passed through an ionic hydrate in the molten state, that is in the fused state, then the options are given, that is hydrogen is liberated at the anode, B option is hydrogen is liberated at the cathode, and C option is no reaction will take place, and D option is hydrate ion migrates towards the cathode. In this case, we have already discussed in the ionic hydrate or salt hydrate, and when this active metallic hydrate undergo electrolysis at the fused state, hydride ion is having H negative, so it will migrate towards the anode. So hydrogen will be obtained at the anode. So option is A. Coming to the next question, that is the molecule of orthohydrogen is distinguished from the para-hydrogen by option A, that is 2 electron moving in the opposite direction, B option is 2 electron moving in the same direction, C option is 2 proton revolving in the opposite direction, and D option is 2 proton revolving in the same direction. And in the case of ortho and para hydrogen, it is the proton spin is in the same direction means it is ortho, and proton spin is in the opposite direction means it is in the para hydrogen. So here they are asking ortho hydrogen. So if the 2 proton revolving in the same direction means it is ortho. So option is D. So coming to the next question, that is a hydrate of nitrogen which is acidic is, A option is NS3, that is ammonia, and B option is N2H4, and C option is N2H2, and D option is N3H. N3H is hydrozoic acid. And option D is hydrozoic acid, and hydrozoic acid is acidic in nature and it is a hydrate of nitrogen. So option is D. Coming to the next question, that is tritium is a radioactive isotope of hydrogen. It emits A option neutrons, B option alpha particle, and C option is beta particle, and D option is gamma rays. So in this case, tritium is a beta particle emitter. So option is C. Coming to the last question, that is when the same amount of zinc is treated separately with excess of sulfuric acid and excess of sodium hydroxide, the ratio of volumes of hydrogen evolved is, A option is 1:1, B option is 1:2, and C option is 2:1, and D option is 9:4. In both cases, that is when zinc treated with sulfuric acid also, and hydrogen gas is liberated, and when zinc treated with sodium hydroxide also, hydrogen gas is liberated. When we are balancing the reaction, we are getting 1:1. That means the ratio of volume of hydrogen liberated is in the ratio 1:1. So option is A. So this is all in this session. Hope you like this session. Stay tuned for the next session. Till then, bye.